Albert Einstein was awarded the 1921 Nobel Prize in Physics. This was obviously in recognition of his ingenious formulation of the special and general theories of relativity. Right? Unright. To find out the real reason, we must start with some history. In 1902, Philip Lenard experimentally showed that shining ultraviolet light onto a sheet of metal, say zinc, can cause it to become positively charged through the emission of electrons. This is known as the photoelectric effect. But why does it happen? Well, Philip, the metal has a potential well that prevents electrons from escaping. According to the theory of the time, the energy of the light wave E is transferred to the electrons, allowing them to overcome the potential well. This required energy is known as the work function phi. By energy conservation, the electron's kinetic energy, Ek, makes up the rest. Now, the wave theory of light predicted that raising the intensity, which increases the power of the light waves, the energy they carry per unit time, would naturally result in the electrons being emitted with greater kinetic energy. But when Lenard conducted his experiment, he found increasing the light intensity didn't have any effect on the electron's kinetic energy. Instead, there were simply more electrons emitted from the zinc sheet per second. To make matters worse, when he decreased the frequency of the radiation, thus shifting it from ultraviolet to visible light, no electrons were emitted from the zinc surface, no matter the light intensity. This was totally unexpected. Surely, physicists thought, if you could shine enough light onto a surface, there would eventually be enough energy to emit electrons. Now here's where Einstein comes in. He realized that light isn't really made up of waves at all, but individual packets of energy. You can have one packet or two, but not 1.5 packets. As one of these photons hits the surface, it interacts with only one electron, transferring its energy to it. If it's enough, the electron is emitted. But low-frequency light doesn't have enough energy, and so nothing happens. This occurs regardless of intensity, as each photon still has the same energy. Borrowing a formula from Max Planck, Einstein resolved the dilemma by stating that the energy of a photon is directly proportional to the frequency of the light. This groundbreaking new idea first showed that energy isn't continuous, but rather quantized. It can only take certain discrete values. Einstein published the theory in 1905, his annus mirabilis, or wonderful year. And it really was wonderful. Quantized energy was a massive breakthrough in the development of quantum mechanics and pretty much all of modern physics. This theory was what won him the Nobel Prize almost 2 decades later. And look where we are now. Lasers, LEDs, semiconductors, transistors, and more all came from this new quantum way of looking at the universe. Without the genius of Einstein, our society would never be where it is today.